searching the best way to test a Grails application from three perspectives: performance, focus on minimizing the time to execute the test; coding, focus on improving the way we write and implement the test; and we also will talk about tips and practices that will help us to maintain the test. The tips we will expose are oriented to the several testing phases available to test Grails applications. Some of the tips are generic or applicable to several phases, while others are specific to a single phase. So let's begin talking about the unit test. First of all, I would like to introduce you an interesting and helpful concept that favors the writing of unit tests over other type of tests, and can tell you how much testing to do on each layer of testing. That is the test pyramid. This basically shows you that for a more integrated kind of test, as the user interface test, functional test in Grails, the time of execution really slows down. So when you decide sticking to this pyramid shape or model, the foundation of your test suite should be made up of the fastest and cheapest test we can write, the unit test. So following up on this idea, you should write a lot of small and fast unit tests, some integration tests because you have methods and parts of the application with more complex behavior. And at this point, you have a lot of tests where you already tested a sort of edge cases and integration between the parts of the system. So there is no need to repeat these tests on a higher level or in your functional test. So the advice is tend to write very few high-level tests to keep the healthier pyramid shape and prevent an inverted pyramid. That is a test suite where there are a great amount of functional tests, a lot of integration tests, and some unit tests. In this situation, maybe you should ask yourself about the way you are testing your application, especially when you are developing and there are some agile methodologies. And the most obvious path to fix this is to convert some of your tests to lower level tests. For example, converting integration tests into unit tests. When we observe a little complex behavior, we tend to write integration tests, but in many cases, the behavior of the collaborators inside the service or method we are going to test doesn't have an important role for testing our method. And the implementation of an integration test can affect our performance unnecessarily. So when we decide to write a unit test, we have to deal with the problem of simulating these collaborators. But Spock Framework and Grails provide many ways to make this unit test easier and faster. The new trait-based Grails testing allows us to test Grails artifacts in a simple and easy way. We can make work the other units we need in an easy way, mocking the domain classes, services, beans, tag libraries, overriding methods, and so on. In the previous version of Grails, some of properties as the message source or the Grails application property had to be mocked or simulated. In the newest version of Grails, all unit tests have these properties available, so you can forget about simulating it and write your unit test easily and save time. We can start to see the implementation of a unit test with the new trait-based testing with a very simple example applied to a controller. For making a controller unit test, you just have to implement the controller unit test trait and pass the controller. In similar way, you can implement a unit test for the rest of Grails artifacts, like URL mapping, tag libraries, interceptors, services, using the corresponding trait. We are going to expose an easy example of writing a service unit test to see the different ways we can deal with the task of making a single unit work when it depends on another unit. As for example, this service has two injected services, and one of them has been defined in our resources file, so we have to provide these things in our test. So first of all, you have to implement the service unit trait, and in this case, also the data test trait to mock the domains with the mock domain method. You can also use the mock domains and specify which ones you wish to test. You can reference your injected service just using the define beans closure, as shown in this code, into your setup spec method or your setup block. And here you can also replace dependencies from a service with a mock implementation from Spock framework, simply instantiating the mock implementation of the service, and then injecting this mock into the service you are testing. Moreover, we can override the method, especially when the method that is collaborating doesn't have any special logic we want to test here. This can be achieved in many ways. In this case, we are using the mock implementation with Spock. And finally, the last step to make work our unit test is to make work the bean used in the mock from the other injected service, using the define beans method again. This makes the bean available from the Grails application property, and in this way you can instantiate it and then inject it into the service. We have seen some useful practices to implement a unit test which needs some collaborators to work properly, but let's talk a little more about mocking collaborators. This can be useful not only on unit tests, but also for integration tests, because this allows you to focus on the functionality under test while delegating the dependent functionality to a mock object. In some occasions, there is certain behavior that you might not want during an integration test, or maybe the behavior depends on the connectivity to outside source, as could be the case of testing REST calls. So in this case, you can override the necessary method, for example, using some groovy metaclass magic, or overwriting with mock implementation, as we have seen in the last sample. And when writing web unit tests, sometimes you need to mock the other web Grails artifact, as for example, controller, or when testing a URL mapping, or when testing an interceptor. Or you sometimes need to mock a tag library in order to test another tag library which invokes tags from this mocked tag library. We have seen how to mock and override services and methods using the mock implementation. In the next example, we would like to show how to use the groovy metaclass to override it. We are overwriting our REST call, defining the REST builder bean in the define beans method. After that, you can You can apply the meta class to the bin, add the method, in this case the get method, put inside all the necessary things to simulate a response. And after that, having this, you can check the other logic concerned with the response from the REST call. Another important and useful topic in test optimization is the way we are using the fixture methods. Setup methods used wisely can reduce duplications on data and makes tests more readable and maintainable. Usually, it's a good idea to use a fresh fixture for every feature method. And to do this, you can use setup and cleanup methods, but you should only use this method if the specification is the same in such a way that all its feature methods require the same resources. To share a fixture, use the setup spec and cleanup spec methods together with the shared annotation to annotate the fields to share. If the feature methods don't require the same resources, an optimal way to perform this is applying the setup and cleanup blocks in every feature method. This way is more efficient because you are creating the specific data for every one of your test cases. So the main key is that setup methods should contain only code that is common to all tests in specification. Otherwise, use setup blocks. This makes the test more readable, maintainable, avoids confusion, and avoids data duplication. So, talking about the setting of data, we can also mention the using of the rollback annotation. When using this annotation, data saved during a test is not persisted to the database, so data is not shared between test feature methods. And this feature is desirable because you don't want your test depending on the order of execution or on the application state. So this allows you to design your test cases independent one from each other. If you want to maintain this behavior, you should be careful about persisting data in the setup fixture method, because the setup method uses a separate transaction that is not rolled back. So this data will need to be cleaned up manually, and you can do it in an easy way, simply calling the delete method in all the entities. But if you are using a relational database, probably you will need you will have to deal with some kind of integrity constraint violation. This will force you to perform the data cleanup in some harder way. The trick, or one of the possible tricks to do it in a fast and easy way, is ignoring the foreign key constraint while delete the entities. In this example shows the way to do it when using a MySQL database, simply executing a query that sets the foreign key checks to 0 before delete all your entities, and restore this value at the end of the deletion process. And now let's talk about creating fixtures utility class. Another good practice is for creating maintainable tests and write it in a more fast way is the using of a fixture utility class that lets you to build and persist data where you explicitly populate the pieces you need and lets the fixture class fill in all the required properties. As you can see in the next example, in one side you can see a test case where you have to create a lot of previous data to finally create your entity. And this could be a very inefficient and expensive work. While on the other side, using the fixture class, this can be reduced to a few lines of code. You can also use the build test data plugin that allows to create instances of domain classes automatically. However, some constraints like custom validator constraint aren't supported, so the fixture class alternative gives you more control over this. Now let's say something about the Bootstrap file when running the application. And this is important to do the less operations during the execution of the Bootstrap. There can be a lot of things we don't need in testing environment. So it's a good idea to execute the specific logic for every one of our environments. This can be achieved using the environment class, where you can specify the logic for every custom environment you have defined in your application. There is another Grails feature that allows asynchronous behavior, including the concept of promises. To use the Grails promises abstraction, you should add a dependency of the async plugin to your build file that is yet included in your Grails 3 applications. To start creating promises, you can use the task method, which returns an instance of the promise interface. And the promises allows you to execute different pieces of code in your test environment inside a task method to execute it in a separate thread. And then in this way, the current Bootstrap thread is not blocked. So the test can be executed before the completion of the task. Another interesting tip we think should be mentioned is the loading of a database dump instead of automatically generating the database tables from GON classes. Importing a database from SQL file can be achieved in your build file, creating a Gradle task for this purpose that will create and fill the database faster. This example is useful for MySQL database and may vary for another database technologies. And first of all, you need to create the Gradle task, where you can invoke a method to import the database properties from your data source definition in your YAML file. And this method having the database properties will create a new SQL instance and execute the necessary queries to import the schema and the data from a given SQL files. Finally, you just need to associate the integration task with the previously created task to restore the database using the depends on method as seen in the code example.
Okay, so I'll keep going from this point. Okay, so another tip to improve the performance of the test suite, in other words, the time it takes to execute, is executing the test in a parallel way. So executing tests in parallel can significantly improve performance. And the Gradle test task provides two properties to execute tests in parallel. The max parallel forks property specifies the maximum number of threads to run the test with, while the for every property specifies the maximum number of tests to execute per thread. And as you can see, that snippet of code, if you put that snippet of code in the build.gradle file, the test suite will run in parallel. So a comparison of performance between running the tests in a sequential way and running them in parallel is here. We have test 500 unit specs with 15 tests each, which makes 7,500 tests in total. And in a sequential way, it executes in 3 minutes and 43 seconds approximately. And executing the same test suite in parallel takes about 1 minute and 59 seconds, 2 minutes approximately. And as we can see, there is a performance gain. However, this performance gain is only achieved when the test suite is very big. In other cases, executing the test in parallel can be counterproductive, and the performance may even decrease. So, in order to execute the test in a parallel way safely, there shouldn't be a shared resource involved. So, a database, the file system, you should take care with that. And this means that for integration tests, if you are using a persistent database, the test may start failing. So you should take care with that, but for unit test, it should be fine. Lastly, the Gradle test stacks also provides 2 properties to disable repo generation, which also may help to run the test suite faster. If we aren't interested in repo generation, we can specify them, and it may help to improve performance too. Okay, another useful tip, this time applied to functional tests, is applying the page object pattern. So, as you may know, the JEP framework is available for Grails by default, and it provides an expressive API which allows to automate a web browser, including the manipulation and checking of DOM elements, using familiar CSS or jQuery-like selectors, which this framework is useful for testing. However, maintaining a growing set of functional tests can be cumbersome in some cases. And this framework, the JEP framework, provides page and module classes which help structure the JEP interaction and can improve the modularity, reuse, and encapsulation of our test code, which leads to better maintainability. Okay, so to show the advantages of this page object pattern, let's suppose we have a web page which we want to test. We want to check the system of some elements in the page, a set of products and a title. The web page simulates the page of an e-commerce site. So without using this pattern, a JEP test has this aspect. As you can see, the navigation URL and the element selector selectors are written explicitly, and we have to make a greater effort to understand what each line is representing, and if we want to make another test which involves the same page and elements, we have to repeat the code. However, using page and modules to represent our page, we can encapsulate in this class the data related with the page, like the URL, the verification that checks that we are at the page, and the elements that are present in the page. And we can even make a module to represent a specific page, a specific part of the page. And in this module, in order, encapsulate its own elements. So having the page and module, we can rewrite our tests using them. And as we can see, the readability improves, and this page and module is able to be reused in other tests. A good rule of thumb to create pages and modules is maybe create a page for each GSP view and create a module for each GSP template. And with Jeb, we can also create page hierarchies to represent pages that may have elements in common. And another good rule of thumb is to write a page for the layout page and set it as the base page for the rest of Jeb pages. So another tip is, also applies to functional testing, is avoiding random waiting times. So for functional web testing, using an arbitrary sleeves to wait for content to be present in the DOM affects performance and maintainability. For example, if we make a Ajax request in our web, the content is downloaded, and we have to wait in some way for this content to be present in the DOM. So Jeb introduces the wait for method to explicitly perform this task, to wait for an element, some content to be present in the DOM. The execution will stop until some condition fulfills, or until a timeout expires, in which case an exception is thrown. So this timeout and retry time for the wait for method are configurable through the get config.groovy file or the arguments to the method. And we can even configure a set of different presets which are useful to test if a loading time requirement is fulfilled. For example, we can configure a quick preset and a slow preset and check if some content is loaded in the time we have configured. Another tip to improve to optimize tests, improve their performance and maintainability, is using a headless browser. So executing functional tests in a headless browser sometimes allows the test to run faster due to the overhead caused by the graphical user interface startup time. And among the system headless browser, we can find PhantomJS, which is a popular one, but Google Chrome has a headless mode too, which is easy to activate. So in Grails 3, in the get-config.groovy file, an environment to run Chrome headlessly is present by default. And in the same way, the Grails task, which download the Chrome driver, and all of this is present by default, so we can easily use it. So a comparison time between executing a functional test suite using a headless browser and a normal browser with graphical user interface, we can see here that using a graphical user interface, a test suite with 60 tests takes about 1 minute 30 seconds, and using a Chrome headless, it takes about 15 seconds less. And that is basically the graphical user interface startup time. If we increase the number of tests, we see that the number is more or less constant. So basically, this overhead is the time it takes to start the graphical user interface. And what we recommend is execute your functional test in a headless browser and use the graphical user interface mode for debugging. Moreover, the headless mode doesn't invade the screen, it doesn't appear suddenly, and you can still work while you are executing the functional test suite. And also, the headless browser are useful for CI servers, continuous integration servers, to execute your test suite automatically. Okay, so this tip and the next one are tips that not only apply to Groovy and Grails development, but in general to all languages and frameworks. And this one is sticking to the single responsibility principle. So classes and methods should have just one responsibility in order not to grow in size and keep the code base well structured and maintainable. Worrying about the testability of the code encourages us to write smaller methods which are easy to test, and a good suite of tests allows us to refactor the code easier. We can depict this relationship as a feedback loop in which good code improves testability and good tests improve code. So, to illustrate the importance of the single responsibility principle, we can see an example. This generate products in text wrapper method receives a list of products. To generate a simple string text report. Inside the method, we iterate over the list of products, and we compute the type of the product based on its price, and it generates the report. However, we can differentiate several responsibilities in this method. We wrote a test for the method. We check that given a list of products, the report is generated as expected, and having the security net of the test, we can improve the initial method distributing responsibilities. We write a method to print a line of the report, another method to determine the product type based on the price of the product, and finally, we rewrite the original method using the other ones. So we can write tests for the new methods that we have created, and keep going with this test-driven development cycle, the red-green refactor cycle, which also encourage to write the test before the code we are going to test also. Okay, so another tip in the same way, which is a good practice which favors maintainability, is writing a small test. This tip is related with the previous one, the single responsibility principle, but from the test perspective. Sometimes a test feature can check too much things, and it grows its size, and the maintainability of the test decreases. So, how we can we improve the size of the test? Well, so a good rule of thumb is divide a test, writing one test for each existing code path. In this simple example, we have a palindrome checking algorithm which throws an exception for empty phrases. A palindrome, you know, is a phrase that is the same straight and reversed. And we can distinguish in this method three possible result paths. True, when the phrase is in fact a palindrome, false when it isn't, and an exception is thrown when the phrase is empty, is null or the empty string. So what do? We write a test to check one of the paths, the path in which the method returns true, another test for the second path, the path in which the method returns false, and lastly, we write a test to check the last path, the path where we throw one exception. This example is a bit extreme, and sometimes you may make sense of checking several code paths in the same test, but in any case, a good rule of thumb is trying to keep the number of conditions per test small so they don't grow in size. And lastly, the last tip is a small one. When you are writing your test with a Spock, in Intellij, you can use a multi-selection function which lets you write type in several lines at the same time, which is useful for writing Spock data tables, as we can see in the animation. Using Alt plus Shift plus a mouse click, we can write these tables, build these tables easily. And this tip is available also for another editors. And to finish, we have here some interesting resources for testing Grails applications. And the slides are available at that URL, so you can review them or spread the word. And that's it. Thank you.
Thank you.